Hello everyone and welcome back. My name is Mr. Kowald and today we are going to be going over the law of multiple proportions. And so just to remind you, in the last couple of videos, this is all leading up to support for the atomic theory. And the three main laws that led to the acceptance of the atomic theory is the law of conservation of mass, the law of definite proportions, and the law of multiple proportions. The law of conservation of mass I dealt with in my first video, and in the last video I dealt with the law of definite proportions. And in this video, I'm going to be dealing with the law of multiple proportions. Just a quick recap on laws and theories. Remember, a law is a general statement of what we observe. The law doesn't try to explain anything. It's just an observation. The theory is what tries to explain what we observe. So in this case, we have three main observations. We have the observation of the conservation of mass, that matter is not destroyed or mass is not destroyed. If you start with a certain mass in your reaction, you should end up with the same mass in your products, and that's what we observe all the time. The law of definite proportions says that if you break things down into their constituent elements, then the ratio of those elements always stays the same. So it's definite proportion. Now, today we're going to be going over the law of multiple proportions. Multiple proportions, this one is probably the trickiest one to understand because it's kind of a little complicated. So this was a theory. The law of multiple proportions was a law that was stipulated or formulated by John Dalton in 1804. Now, John Dalton is the father of modern atomic theory, and in my next video, I'll talk about Dalton's theory, Dalton's atomic theory, and his four postulates. So Dalton basically said that when you have two elements, and we'll call them A and B, when two elements combine to form two different compounds, the masses of element B that combine with 1 gram of element A can be expressed as a ratio in small whole numbers. Okay, that's a mouthful. What is he talking about here? So Dalton already suspected that matter and mass and everything was made out of small particles. This is what he suspected. And so under that suspicion, he then hypothesized, well, if everything is made out of atoms, then if I have two substances that are made out of the same elements, then the only way that those two substances differ is in the relative number of the atoms that make them up. So, so here what he's thinking is, if I have two substances made up of the same elements, but they're different substances, then what makes them different has to be the number of the atoms. So, but they're the same elements. So this one would be 1A, 1B. This one would be 2 B's for every 1A. This would be 3 B's for every 1A. So the only way that these substances differ is in the number of B's. So if that is true, then one would expect that if you were able to figure out the masses of these elements and figure out what the mass of element B in each of these compounds are and relate it to a particular mass of A, say 1 gram, then the different masses of B related to that 1 gram of A would be a whole number ratio, because the difference in the number of B's is going to be a whole number. So under that suspicion, well, he found out that if you took carbon monoxide and carbon dioxide, both substances, both gases that were known to be made up of the same elements, but they have different properties, and so therefore they're different substances. So under the suspicion that you could find out the amount of oxygen per 1 gram of carbon. So you found out that the mass of oxygen that combines with 1 gram of carbon in carbon dioxide is 2.67 grams. Then you do the same analysis of carbon monoxide, and you find that the mass of oxygen in this case that combines with 1 gram of carbon in carbon monoxide is 1.33 grams. So then you take these two masses of the oxygen and you put them in a ratio, and here you can see that the ratio is 1 to 2. So this is a small whole number ratio, and so this goes with the theory, the atomic theory that Dalton was postulating, or thinking that was true. So this is called the law of multiple proportions, because the proportions between the oxygens and the carbon are different, but you can get a whole number ratio between the two different masses. So again, this would be expected if all you are in your substance are atoms, and if you have the same elements in your compound, then the only way that they're going to differ is by the different numbers of atoms of each of those elements. And so that would lead to a same proportion between the amount of that one element, oxygen in this case. So I hope that is helpful. So these three laws are consistent with the theory of the atomic theory. So the atomic theory was accepted as an explanation of these observations. I hope this was helpful. If you like this video, go ahead and subscribe, share the video, make a comment in the comment section if you want me to talk about anything else. Ring the bell for notifications, and I'll see you next time. Thanks for joining me.